Hi everybody. In lesson 9, we vertically stretched and vertically shifted up and down our sine and cosine functions. So number 1 says sketch one cycle of each of the following functions. So if I look at all three functions here quickly, I have a sine curve. And we know our basic y equals the sine of x has 5 key points. We start at the midline. Go to the max, midline, min, midline. Sine is a little hill and a little valley. The highest it goes is 1, the lowest it goes is -1. Don't forget to label your max and min, and you have to label the period when you draw one cycle. The period of the sine curve normally is 2 pi. We play around with that tomorrow, so for today, make sure you're marking everything 2 pi at the end of one cycle. So, if I have f of x equals 4 sine of x, I have an amplitude of 4. I have an amplitude of 4, which means I vertically stretch it by 4. So this sine curve is still a plain old sine curve. Midline, max, midline, min, midline, little hill and little valley. But I vertically stretched it by 4, so the maximum is now 4, the minimum is now -4. I didn't touch that it ended at 2 pi for that one cycle, because I'm only graphing one cycle here. Remember, this goes on and on forever, it oscillates back and forth. But here I'm only graphing one cycle. G of x equals sine of x minus 6. That minus 6 is stuck on at the end, so I have a midline of not y equals 0, I have a midline of y equals -6. So I shifted it down 6 units. So if that's 0, my new midline is down here at -6. My amplitude is still 1, so I'm going up 1 and down 1. Sine starts the midline, goes to the maximum, midline, minimum, midline, still 2 pi. Maybe you should label the x-axis up there, 2 pi. That stops after 2 pi. So notice how I went to my midline, and then I went up and down my amplitude. So I went to my midline. Normally it's y equals 0, but here I shifted it down 6, and then from there I went up and down the amplitude. And finally, this last one here, I'm shifting down 3, so y equals -3 is the midline. But be careful. The amplitude is 2. Amplitude is a positive number. The amplitude is 2. The negative means reflect over y equals x. Reflect over the x-axis. Reflected over the x-axis is what that negative means. So instead of doing a little hill and little valley, negative sign is a little valley, little hill. Negative sign is reflected over the x-axis there. So my midline is down here at -3. Let's label that 0. My midline is down here at -3. I'm still going up 2, because my amplitude is 2, and down 2. Except I need a little valley first. So I'm going to go down because that number out front is negative. There is my sine curve. There's one cycle of my sine curve, and it stops at 2 pi. It stops at 2 pi. I started at my midline. I said my amplitude is 2, so I went up and down 2, but because I have that negative in front of it, that negative tells me to flip it over the midline or reflect it over the x-axis and then shift. So I would do a little valley, then a little hill. State the range, midline, and amplitude of y equals -7 sine x plus 2. So I want the range, midline, and amplitude. Well, the midline is an equation. The midline is not just 2. The midline is y equals 2. Midline is y equals 2. So let's graph this here. So there's 0. Call that 2. My amplitude, my amp, is 7. Positive 7. My amplitude is always a positive number. That negative is just telling me I'm not doing a little hill, little valley. I'm reflecting it first and going little valley, little hill. How far up and down do I go from 2? Up to 9, up 7, and then down 7 to -5. So my curve here looks, I'm at 2, I'm making my valley first, then my hill. And again, you can't forget to label that it stops at 2 pi. You cannot forget to label that one cycle stops at 2 pi. The only thing I still have to talk about here is the range. The range is my y values. How low does it go? The lowest it goes is -5. The highest it goes is 9, and we include those, so we use hard brackets, square brackets there. So we have our midline, our range, and our amplitude, and a sketch. Sketch one cycle of a sine function with an amplitude of 2, so I'm going up and down 2 from y equals a half. Y equals a half. I'm sketching this so I can do whatever I want here. That's a half. So I'm going up 2 to 2.5, and I'm going down 2. If I'm taking 2 away from a half, that brings me down here to negative 1.5. And since I'm graphing a sine function, I know sine functions start on the midline on the y-axis. I'm going to assume it's a positive amplitude leading coefficient out front. And say here is my sine curve. We cannot forget to label that it stops all the way over here at 2 pi. Doesn't matter where it lands, but you have to have that label there, that the period of one cycle, they're only asking for one cycle here, is 2 pi. Sketch one cycle of each of the following functions. So we've been playing with sine, let's deal with cosine here. We cannot forget about cosine, the cosine curve. So quick reminder of cosine. Cosine starts up high and makes a big valley. That's the cosine of x. But if I have a negative cosine of x, I reflect it and flip it. That negative out front does a reflection there, so that's minus cosine of x. So if the leading coefficient in front of cosine is negative, I have to do that reflection. So I have f of x equals cosine of x plus 3. So my midline is y equals 3. My amplitude is 1, so I have 3. From there, I'm going up 1 and down 1. So cosine starts up high normally. Cosine starts up high and makes that beautiful valley. That valley ends at 2 pi, just like sine does, because we said it takes 2 pi radians to spin around a circle into one full rotation. G of x equals -4 cosine of x. Okay, but it's an amplitude of 4, but I also have to flip it. So cosine normally starts up high, so because I have that negative, I'm going to start down low with -4. My midline didn't change. My midline is y equals 0, and I have to go up 4. So the cosine is going to start at the minimum this time because I have that negative out front. Midline, max, midline, minimum. And as I sketch in my lovely cosine curve, instead of being a big valley, it's going to be one big hill. And that took me 2 pi radians to get there. Finally, h of x equals 6 cosine of x minus 2. So we've got both transformations going on here. I've got a midline of y equals -2. So I've got a midline now of y equals -2. Call that -2. And an amplitude of 6. So from there, I'm going up 6 to 4, and then down 6. 2 take away 6 would bring me to -8. It's a positive cosine curve, so we're starting up high. Midline, minimum, midline, maximum. How long did it take me? It took me 2 pi. I'm going to label that 0 there to label my x-axis of it took me 2 pi radians to do one full spin. So cosine is basically the same as sine, except it's just a different pattern. It makes that valley or that hill instead of a little hill, little valley. It's just one big hill or one big valley. Graph two cycles here of the sine function. So I'm thinking of sine, maybe draw a little sketch, whose amplitude is 3, whose midline is -2, n passes through the point 0, -2. So I got a sine function with a midline of -2. I always start with the midline. And from there, I'm going up 3 and down 3 to 1 to -5. I'm graphing a sine function, so I should be starting on the midline of 0, -2. And I need 2 cycles of this. So I normally go over 1 and graph those 5 key points. On my x-axis there, I'm going to label that 2 pi because it took me 2 pi radians to do one full rotation. And I got to do it again because I want 2 cycles, so I can just do that same direction, or you could have said I'm going to go backwards and do it that way. But either way, I'm going over 1 and to the midline, maximum, or minimum. So if that was 2 pi, that took me 4 pi to finish that cycle there. So make sure you've labeled your max, your min. Make sure you've kind of drawn in your midline. And the key thing is labeling your period there of saying this is how long it takes to do one cycle. Because it doesn't take 4, 1, 2, 3, 4. It doesn't take 4 boxes. It takes 2 pi radians to get there. And finally, number 6, determine the amplitude and midline of the function below and write an equation for it. So when I look at this, the first thing I say is, the midline appears to be like here. That appears to be the middle of this function. On the y-axis, it's at a highest point, so I'm thinking this is a cosine curve. I'm thinking this is a cosine curve, which we see here. The amplitude, well, that's how far away am I from the midline. I don't know what the midline is yet. So the highest I go is 9. The lowest I go is -5. What's in the middle of that? What's in the middle of that? So that's not, they're 14 apart. So I need to go 7 away from that, or 7 away from that. The midline appears to be 2. So maybe I drew mine a little too high there. Maybe I drew my midline a little too high there. Let me erase that. Goodbye. So I need to find my midline. Here, we'll do it this way. What cuts this in half here? Where is the middle? We'll call that the middle there. My amplitude, this entire distance is 14. The amplitude is midline up, so I need to be 7 away and 7 away. So what's my midline here? My midline appears to be 7 away, y equals 2. Y equals 2 appears to be my midline. And I have an amplitude of 7. So when I write my equation of this, I say y equals, because it has to be an equation, of I know it's a cosine curve. I know it's a positive cosine curve, and I have an amplitude of 7, and I have to shift it up 2 for my midline of 2. So this is y equals 7 cosine of x plus 2.